Today on Engineering Newswire, we're healing plastic with a drop of water, 3D printing new skin, and setting a new speed record for electric vehicles. Many materials are already self-healing, but now researchers have developed a plastic that has the ability to repair itself with just a drop of water. Derived from the genetic code of squid ring teeth, the two-part material consists of a soft amorphous segment and a more structured molecular architecture. The amorphous segment is what gives the material its self-healing properties, its counterpart, its strength. To test the material's abilities, the researchers created a dog bone-shaped sample and cut it in half. Then, using just a few drops of water and a little pressure from a metal tool, the sample healed itself. But to be sure, the team conducted strength tests to prove that the material was as strong as the original shape, even after being cut in half and healed with water. Someday, this technology could be used to extend the life of medical implants, fiber-optic cables, and other objects in hard-to-reach places. Drop a little water in there. The researchers even think that in the future, the approach could be applied to healing wounds.
The Bonneville Speedway in the Salt Flats of Utah has hosted motor sporting events since the early 1900s. Numerous land speed records have been set and broken there. On August 21st, French electric car specialist Venturi and the Ohio State University Center for Automotive Research teamed up at the Bonneville Speedway to set a new speed record for electric vehicles with the Venturi Buckeye Bullet 3 Streamliner. Propelled by two custom electric motors, the Streamliner is powered by over 2 megawatts of lithium-ion batteries. Unfortunately, the Salt Flats have received a lot of rain this year, leaving the salt slushy and a little clumpy. And although the track is traditionally 12 miles long, the Streamliner was forced to race on a 10-mile-long track due to the poor conditions. However, the electric vehicle was able to reach a record speed of 240.32 miles per hour, breaking the world record in the 3.5-ton category. It may sound impressive, but the makers of the vehicle had expected to reach a speed of around 440 miles per hour. And no, the vehicle is not bleeding. The bumps were so bad that the coolant tank cracked on the rebound run. Sadly, the incident eliminated a possibility of a subsequent attempt. Here's to hoping next year's a little drier.
3D printing has come a long way in the medical industry. We're printing heart valves, bionic ears, even skin and liver cells. While some might find these advances staggering, others continue to ask, what's next? Well, researchers from Tufts University may have your answer. The team has developed a silk-based ink that could open up new possibilities in 3D printing complex tissues. Instead of just printing your ordinary run-of-the-mill skin, what if the tissue could be 3D printed with pharmaceuticals, let's just say to help treat burn victims? Most inks are currently made of thermoplastics, silicones, collagen, and gelatin, but there are limits to how they can be used. For example, the temperatures required to toughen up some of these materials can damage cells or biological components. To address these bio-ink limitations, these researchers turned to silk protein and developed a way to avoid these harsh processing conditions. The researchers combined biocompatible silk proteins and glycerol. The result is a clear, flexible ink that is stable in water and doesn't require any processing methods that would limit its versatility. Well, because of their work, the material can be used in everything from biomedical implants to new tissue engineering.
Do you have store ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm Melissa Fossbender, and this has been your Engineering Newswire.